Good afternoon, ma'am.
Hi, good afternoon. Am I audible?
Yes, ma'am, you're audible.
Okay, let's wait 2-3 minutes. Let everyone join, then we'll start.
Okay.
Okay, so last day we did up to matrix multiplication, right?
Yes,
So
ma'am.
today we'll start with scope of variables. Let me share my screen. Okay, someone called PS Kiran, I think, they sent me a mail regarding a particular problem statement where it is the problem is that how to find all possible permutations of a given word. So I have the code for that and I'll explain it at the end if that person is present. Okay. Okay. Can you see my screen? Hello? Is my screen visible?
Yes, ma'am.
Okay. Okay. So scope of variables. So there are two types of variables. Okay. So we have local variables and we have global variables. So local variables are those variables who only change their values and maintain those values within a particular function. And global variables are those variables whose value will you can work with those variables throughout the entire program. So the scope of a local variable is just inside the function in which it is used, but a global variable can be used anywhere in the program. Okay, but what we can do is sometimes we take the value of a global variable and we work it with it inside a function. Okay, but as soon as we take it inside a function, it becomes a local variable. So even if you change the value of that variable inside the function, it is not globally changed. So just inside that function, the value will be updated, but it is not actually changing the value in the memory. Okay, so let's take an example. So let me define a function. Let's call it my function one. Will have some variable x as the parameter. Okay, now let's say this function just multiplies x with 2. Okay, and then we'll print the value. So print value of x in function 1. So this means that it will print the value of x that is changed or updated in this particular function. Okay, so x. Now this is the function definition. Now outside of this, in the main program, we'll declare a variable called x and we assign it the value 5. Okay, so this is outside the function. This is in the main program. So here if I print this, that is, let's write print value of x before function call. Then we will call the function that we wrote. So my function 1, and we'll pass x as the parameter. And then we'll again print, just to see the difference, print value of x after function call. Okay. So now you tell me, what do you think this first statement will print, this print statement inside the function? What should be the value of x here?
10.
So it should print 10. What should this second print statement print, this line 6?
Ma'am, can you please zoom
Yeah.
in, increase the font?
Okay.
Yeah.
So what should this second print statement print? What do you think, this
5.
line 6? So it should print 5. Okay, then I called the function, my function 1, and after calling it, then I'm again checking that what the value of x will be printed outside of the function once I've called the function. So according to the function, x's value has been updated. So when I print x outside of the function, what should line 8 print?
None.
Will give 10.
Should it print
10.
5 or should it print 10?
10, ma'am.
10.
10.
So everyone is saying 10. Okay, let's run this. See. So the result is, first line is value of x before function call 5, that is this print statement from line 6, this is fine. And then we have value of x in function 1, that is inside the function, since we have called the function in line 7. So now control shifts to the function definition, passes x as parameter, and prints line 3, this print statement. So now 10 is printed, but look at the third line, that is in line 8, when we again issue this print statement. So this is printing x as value as 5 instead of 10. So why is this happening? Because this second line, that is printing 10, okay, this is inside the scope of the function. So here x is passed as a parameter, and then x is multiplied by 2, then we print the value as 10. But this is happening locally. Okay, just inside this function, x's value has been changed. Globally, x's value is still 5. So this line 5, where I have assigned x the value 5, this is a global assignment. So this variable x outside of the function itself is a global variable. When we take it as a parameter in the function, it becomes a local variable inside the function. So no matter what you do with that x value inside the function, it will not change the value globally. That is, the actual value of x in the main function remains 5. But inside your my function definition, when you execute that function, x will print 10. So the value of x is updated just locally, and the scope is just this function. Okay, once this function is ending, that 10 value is not stored. Okay, so you can think of it like, when we call this variable inside the function, we create a copy of it. Okay, and we make the updates or the changes in that copy, not the actual global variable. So that's why the third line is still printing value of x after function call is 5, because globally x is just storing 5, not 10. Is scope clear?
Yes,
I
ma'am.
still have confusion.
Okay, which part is confusing? Tell me. First, this line, is it okay? Print value of x before function call, it should give 5.
Yes. Yes, ma'am.
Okay, then I called the function my function 1 with parameter x. So it is taking the value of x, just the value. Okay, just this 5 value it is taking. And then inside the function, it is changing that value to 10. And here I am printing value of x in function 1, that is 10. So this x inside the function, okay, think of it like a copy of the actual x variable. It's a copy. It's not the actual global variable. So why do we need this copy? Because whenever we use a variable, okay, inside a function, so the scope of that variable is just that function only, not the main program. So we will work with that copy of x. So there, when you print x, it is printing whatever is being stored in that copy. We are making all the updates in the copy of the variable, not the actual global variable. So after that, after you have printed 10, then when you again print outside of the function, that is in the main program in line 8, when you again print that what is the value of x after function call, so now it will print the global variable, not the local copy. Okay. So whenever you print x inside the function, it will print the updated value. But whenever you print x outside of the function in the main program, their x's value hasn't changed. So global variable scope is throughout the program, and local variable scope is just inside a function.
Okay, ma'am.
Okay, let me see if I have one more example. Yeah. So let's add one more function definition here. Let's say def my function 2. Here also I'm taking x as my parameter. Then this time let's multiply x with 3. And again I'll issue one print statement, just copy paste this. So value of x in function 2 is x. Okay. Now here I called my function 1x. Let me also call the second function my function 2x. So now what do you think will be printed in this? Okay, first tell me what will be printed here. First line 10 will be printed, right? So the program starts where? From line 9, where x is assigned the value 5. Then we print the value of x before function call. So here what should be printed? X value should be what? Line 10?
5.
5. Then we call my function 1x. So control shifts to this function. Here what will be printed as x value? 10.
10.
Then we again call my function 2.
15.
Then here x value should be, we are saying 15.
Yes, ma'am.
Okay. And then we come to line 13 and again print x value. So what should this print?
5.
5.
They should
5.
print 5, because these two lines, line 10 and line 13, these print statements are in the global scope, like in the main program. These are not inside a function, right? So let's run this, see if you are correct. Yes. So first statement is value of x before function call is 5. Second statement comes from your definition of my function 1. From there we print x. So this is the local variable which is changed to 10. Now see how I know that x's value is actually not changed globally. Because if it was globally changed to 10, and then you called my function 2, then x should be updated to what? It should be 30 then, right? If this 10 was being stored globally, then that x value should be 30, right? Because when I call my function 2, then it should pass that 10 value as the parameter, but it is still passing the 5 value. That's why you're getting 15. So this is a proof that we can check that x is a global variable and these x's inside the functions are local, right? Is it clear now?
But ma'am, I think you have generated for 4 functions, 4 print statements. And here the first print statement is giving us that value of x before function call is 5. But
Yes.
why it is giving us? We don't require it, na?
I am just showing you that how the local and global variables are working. So first when I assign x the value 5, and then I print, and then I'm printing this value of x before calling any of the functions. So currently x's value is 5. Then you call the first function with x as parameter. So it
Yeah.
takes that 5 value, right? And inside it prints the value after updating it, and that is the local variable x. Inside my function, it has the value 10. Then when I'm calling my function 2x, right? So
Yeah.
this in my function 2 parameter, what is the x value that is being generated here? What is the value of x that I'm taking as this parameter in my function 2? 5 or 10?
5, we are taking 5.
We are taking 5 because, see, this is the proof that it is a local variable, this 10 value, because if it was global, then x's value would have been updated to 10, and
Yeah.
then my function 2 should give me 30 as answer, right? But it's giving 15 because x is a global variable. So every time you're calling a function in the main program with x as parameter, it will take the local value, global value, not the local one.
Yeah.
Okay, so that's why line 3 will, that is this, my function 2 will print 15, but then after calling both these functions, when you again issue a print statement in the main program, then x's value will remain 5 because globally it's not been updated. If I globally update x to 10, if I write here that x is 10, and then again issue this print statement, Let's write current x value, and then if I print x, so see,
10.
now it is updated to 10 because I changed the value of the global variable in the main program, not inside a function. Okay. So this is scope of local and global variables. This is very important when you write a lot of functions in a particular program. Then local and global variable distinctions are very important. Okay.
Oh, so x here is a global variable.
Global variable, this x that I declared in line 9 is a global variable. So whatever variable is not inside any function, the variables which are declared in the main program, they are global variables. So
Yeah.
their scope is throughout the program. That is, they will maintain their value throughout the program. But any variable that we are working in inside a particular function, those are local variables. So they are local to that function only. Whatever update we make to them will not reflect in the main program. It will just reflect in that particular function.
Ma'am, for global variable x is equals to 5, value of x, which you have written value of x after function call 5. I could not understand that.
This line 13.
Yes, ma'am.
So I called both of these functions, right? In both functions, x's value was updated, but these updates are made locally. So none of these values are actually stored in the global variable. So these 10 and 15 values are valid only inside these functions. It is not changing x globally. So globally, x's value is still 5. So when you again call the print statement and you print x outside in the main program, x will maintain its value as 5. Okay. So global variables maintain their value throughout the entire program. And local variables are just making a copy of that x. And we are just updating that copy, and its scope is just inside the function in which we are using it.
Then my function 1 and 2 are the local variables?
Yes. My function 1, here this x that you are using, this is a local variable. This is not global.
Why don't it take second value of x is equal to 10?
Which value?
Why don't our function takes x is equal to 10 and print 20 and 30?
In this function 2.
Yes.
Because when you are calling function 2 in line 12, right, this has nothing to do with function 1. These are two separate calls. So whenever we are calling a function in the main program and passing x as parameter, it is taking a copy of the global variable. So globally x is 5. So every time we call a function inside the main program, it will take 5 only as parameter. This change that happened in my function 1, where x was changed to 10, this change is local.
In line 9, you were taking the value of x is equal to 5, and in 14, it changed the value of x. And
yeah, but the
now
change is happening inside the function only, right?
Okay.
Inside this function, x becomes local. That is, this is just a copy of that global variable value. It is not the actual global variable.
Okay.
Okay. So whatever we print inside the function, the scope is just up to that. Even though x became 10 inside my function 1, this is not changing the value of this main x variable, this global variable. It is just a local copy. And once the function is over, it is not valid anymore. Yeah.
Ma'am, if you write line number 11 after line number 10, 9,
Nothing will change.
it will work.
Line 11 after which line?
Like first line number 9, then line number 11, then 10.
Okay, no problem. See, if I just remove this here and
Like function call before.
this,
then
okay, this, right?
Yeah.
So now what will be printed? So this is x is assigned 5. Then I call my function 1 and put x as parameter. So it will go to my function 1, print the value of x after updating. That is 10. So first it will print 10. Then it will
like
come to line 11.
Function call first, na ma'am? Then print.
Yes. First
Okay.
function call. Then inside the function call, you are printing the value of updated value of x. So first print statement will be 10. X's value is 10. Then you come to line 11, print the value of x before function call. So here this print statement is calling the the global variable x, not the local one. So this will still print 5. See, if I run this. See, first value of x in function 1 is 10. then value of x before function call is still showing 5 because this is the global variable. Okay, again value of x in function 2 is 15 because this 5 only is being sent as parameter to my function 2.
Ma'am, can I say local variable is that variable whatever I am written variable in inside the function?
Inside the function, yes. Whatever variable we are using inside the function are local variables.
And outside the function we can change that variable, that is a global.
That is a global variable. So here when I changed in line 15, when I changed value of x to 10, right? Now after this, if I call my function 1 again and pass x here. Okay.
So it will
So
take the value of 10.
now it will take x as 10 and it should show me 20. Let's run this. See. Now here the value of x in function 1 is 20 because now the global variable has been changed, but in the main program, right? Not inside a function. So global variable, you can only change the value globally. Locally, whatever updates you are making, those are just local copies. They are not valid after the function is over. Okay, is it clear? Any doubts?
No, ma'am.
All right, so scope, we just have this much only, local and global variable, what they are. So if you understand this, I think that is enough. So now we will go to some more functions. Okay. Oh, you want these codes, right? Let me save this.
Ma'am, you can paste the code on Colab. And
Yeah, I haven't created that collab file yet. If you have a file that is already created, can you share it with me?
Colab file means I can't add your codes, but
No, just share the file with me. I'll add the code.
mm,
Or where are the other instructors? Are they uploading it on some collab file?
Piyush sir, when Piyush sir used to take classes,
Yeah.
he attached the Colab files.
Okay, so I'll talk to Piyush sir and I'll attach them.
Or our codes TA, you can talk with our codes TA Mrinal, who use Colab.
Okay. Okay. Okay, let me ask Piyush sir after this class. I'll upload the notes there. Alright. So now scope is over. Now next thing we need to understand is what is a list iterator. Okay. So very simple way of understanding this thing is that when I run a normal for loop, right? Any normal for loop. So let's say I am iterating through the items of a list. Okay, let me make a list. Let's say this fruits list, right? So inside this, let's put some fruits like mango is one element. Then we have apple. Let's just put a few elements. Banana, orange. One more. Let's take pineapple. Okay, let's say this list has 5 elements, right? Now, if I iterate through this, okay. So if I want to print all of the elements in this list, so what should be my code for a for loop? For I in range?
For X in range fruits.
I in range fruits.
Or
Just saying.
for I fruits.
For I in fruits, that's right, because
Right, not
range is not required.
required.
So we can just print I.
Print I.
Right. So this is printing all of the elements at once. Okay. Now what if I want to print one element at a time? Okay, and I'll print the next element when I require it. But I still want to traverse the entire list, but not at once. So whenever I am traversing the list as a loop, then it will print everything at once because the loop will iterate until the loop variable is out of range. Right?
You can do that for a fruit of 0 print.
Yeah, but let's say I want to keep the loop. Okay, I want to keep the loop, but I don't want it to print everything at once. So here what we can do is we can use something called a list iterator object. Okay, so how can we create such a thing? See, so first let me remove this.
Ma'am, can you please zoom in?
Yes. Okay, so let me take some variable called basket. Okay, so inside this I'm writing iter. This is a function. Okay, and it will take fruits as its parameter. So now when I write, just to see what this basket is, okay, since inside basket I'm assigning this iterator function, okay, it's called iter, and it's taking this fruits as its parameter. So when I print this to see what this basket is, so let's write print basket, see what it is giving. So it is saying it is a list iterator object, right? So basket is this list iterator object that we have formed. Now why do we need this? So what will happen after this, if I issue a print statement, right, and I use a function that is called next, so I have to write print next basket. Okay, so it will print the next element in the basket. So this will only execute when I write this print statement. So for every single element I have to write this print statement again and again. So this way you are still using an iterator, but it is not printing everything at once. So this thing, this iter function that I assigned to basket, so this made this basket a loop, a list iterator. Okay, so this is called list iterator object. Let's see how this will work. So if here I write print next of basket, now if I run this, so it just printed mango. Okay, so first I created the list iterator object, that is the basket itself, right, with the iter function. So the iter function will take the list in which you want to iterate, and basket becomes that list's iterator object. Okay, so every time we call this list iterator object with this next function, so it will go through one after other element. So after this, if I again write print next basket here, now run this, so it will print mango, then apple. Okay, so as many times as you write it, only then it will print. So it is kind of like, let's say I am like the example that the professors used is that if I have a basket of fruits and I want to distribute them among some children, right? So how will I distribute? Let's say I have 10 fruits. Now I am going along the road, I see one child, I give him a fruit. But I won't get all 10 children at once, right? So whenever I see a child, I'll give them a fruit. So I don't need to pick out all 10 fruits at once. I need to pick them out one by one. So this is what this print statement, this next function is doing. So whenever I see a child, I issue this print statement that give me the next fruit in the basket. So this is what it does. Okay, list iterator object just iterates through the list, but you can control when you want to print the outcome. Okay, instead of a for loop that will go through all the elements at once, here you have the control when you want to print the next element. Is this clear?
Ma'am, can you explain 3, 4 line number 3 and 4?
Ma'am, suppose a scenario like I see a child and I want to give the fruits like banana for this child. That time,
No, you have to go through the list in order. You cannot change the orders because the iterator will move just like a for loop only.
yeah,
So it will go one after another.
That time, what type think I can use for loop or we can use.
If you want to pick a particular element in a list, then you just have to go through the index, right? If you want to print banana, you have to write print L of 2.
Ma'am, so yeah, iterator.
There the list iterator won't work.
Ma'am, so here list iterator working as a function to find out the every element next to each other from the list.
Yes. So this is what we call an iterator. Okay. This basket becomes an iterator.
Oh, so ITER is a short form of iterator you are using here.
So this iterator function, whichever whatever parameter we put into this, like a list, I put the fruits list as a parameter in this iterator function. So it will create an iterator for this loop, for this list. Okay, that will iterate through every element in the list. So the basket becomes that iterator. So whenever we say next of basket, so it will go to the next element in the fruits list. So basket becomes the iterator for the fruits list. Okay, the only thing that it does is different from a for loop is that for loop will print every item at once in one call, but here you have the control when you want to print the next item.
That means, ma'am, suppose in first print statement, the cursor is at mango. When we call in second time, the cursor shift to the apple.
Yes, it will go to the next element.
Next element. In suppose 100 lines of code, and at the last line, I am calling this next basket. That time it will be the next to this
Yes, see,
previous.
if I just copy paste this statement few more times, let's say print basket, print basket, print basket. So 5 elements I have given. So now it is printing all 5. Okay. So for every element that you want to print, you have to write this print statement, the next function. So
Once basket is empty, it will give error.
If basket is?
Empty.
Basket is just the iterator. Okay, it's just a variable that is iterating through this fruits list.
Okay.
So basket is not the actual fruits list. It is just iterating through the elements. Like we use an I, like the iterator variable in a for loop, right? So I is not the actual list. I is just going through every element in the list. Similarly, basket is also just going through every element in the list, but it is not printing everything at once. So you can control which element you want to print when, but you cannot change the order. It will go in the same order as a for loop.
Ma'am, you just write after this coding, again if you copy paste, will it show mango?
It won't show anything because now it's empty. Okay. So once the fruit basket, all the elements you have iterated through, then it won't. It will just stop.
Okay. In that case, it will show an error, or it will say.
Yeah. See, it's what is it giving? Print next basket. So it has to stop the iteration because no more items are present in the basket. You have already iterated through everything. So next is nothing.
In this case, like in terms of the computational power as well as the time, is it like a longer process compared to a regular for loop?
It is longer. Now longer in terms of what? So you have to decide that when you want to print it. Okay. It is not going to print anything until you ask it to.
Okay. And I mean, is it the only way that we need to print for each and everything, or is there a way that we can actually put this print statement can be done in a better way to not to print multiple print statements?
No, that is the whole point. That every time you want to print an element from the list, you have to issue the print statement. If it did everything at once, then we can just use a for loop for that, right? In some scenario, you might need to access elements one by one at a particular time. So that time you can use an iterator.
Here, sorry, I actually joined almost like just 5 minutes ago. When you have defined it as a list, right? There, so it's kind of going through indexing process. So can we also can't we do the same print statement in the same indexing way? Like saying that instead of having a multiple thing that we do normally previously exercises where we are doing.
So you want to use like a for loop.
Yeah, because like instead of a multiple print statement, can I use
that is the point of this.
for
Okay.
going through this?
The list iterator object, the point of using a list iterator object is that you don't want to print all of the elements at once. So this print statement you will issue when you need to extract an element from the list. You can just create this iterator called basket, and you can just leave it like that until you need to extract an element.
So you mean to say that like if I have 100 elements inside this, I just want to print the first 5, then I have the control over it, and I can print only the first 5.
Just print 5 print statements, and you will get the first 5 elements. Okay.
Ma'am,
so
hello.
There is
Ma'am, this attr function not discussed in any lecture of professor?
Yeah, it is there. It's in one of the last lectures, I think 6 or just the lecture after the scope of variables. I think it's lecture 8 maybe. Okay.
Because I totally missed your lab session. I don't know about lab session running there. So
No, it is in
this
week 5,
type of
lecture 8.
concept missed.
Week 5, lecture 8 has this list iterator objects. Okay. 7 or 8, just check it once. Just the lecture that is after the scope of variables.
I totally missed the whole lab session previously. So
Yeah, that is already present in YouTube, right? So you can watch it there.
yeah, okay, ma'am.
Ma'am, are you seeing the lectures and?
Yeah, I have seen all of the lectures. Now, in summary session, what we do is that we summarize all the concepts in the lectures. And then programming session, you will program based on these concepts.
So, ma'am, I am asking you something. Can I take a risk to quite seeing the lecture of the professor and directly join your session?
I would say that watch the lectures of professor first, because see, he takes a lot more examples when he's doing this, right? So he has like 10, 11 lectures per week. And each of those lectures are some 10-20 minutes long. So since
No,
he has
10-20, not 10-20.
40 minutes also, yes. I have watched all the lectures, but the thing is that when he is writing the code, right, he takes a lot of different scenarios into account. What I am doing is I'm just giving you the crux of the matter, that what the entire thing summarizes to. But if you want to see what other, like what can be all possible implementations, so when we went through tuples, lists, dictionaries, so he gave you a lot more examples in those lectures. So it's very useful. Okay. Some of the summary lectures, like some lectures like more on dictionaries, more on lists. If you think that you can skip those and know those concepts still, then you can skip them. But I would suggest you watch all the lectures. They're very informational. Okay.
And here, I mean, it is going to be in the kind of a queue form, or actually I have the liberty of skipping the elements, like where I print only mango, banana, and
No,
missing it.
you have to
Not
go
possible.
through every element. Okay, one after another. It is similar to traversing using a for loop. Just instead of a for loop, you have the control when to print.
And this iteration can, I mean, I think you'll be discussing in the future, I think. So this iteration thing is like a function that can be a global function that I can call anywhere.
Yeah, this iter function, right?
Yeah.
Yeah, you can call it anywhere with any parameter you want.
Thank you.
So what we can do is to better this. Now, do we always need a list, a separate list, and then create a iterator function based on that list? So why can't I just directly generate an iterator instead of writing all of this? Right, I can just directly generate an iterator. So that type of a function, like instead of having a separate list, I just have a function, okay, which will generate an iterator. So that can be in general for any list I can, or any data structure that I can use it for. So instead of using a separate list and a separate iterator variable, now what will I use is called a generator. Okay, so it will automatically generate the iterator. Instead of using this iterator function, now I'm going to show you how I can do this using for any general function. So I can do the same thing that I'm doing here. Okay, but I don't need a separate iterator variable like basket. See how I can do that. So I'll just remove. Okay, let me save this. Okay, let's define something. Yeah.
Yes, so once you're done with this process, can you please explain the global and local variable concept once again?
Okay, yeah. See, let's define a function that finds the square of a number. Okay, so let's say square, and I'll give it some limit. Okay, so let's take a variable x, assign it the value 0. Then I'll run a while loop until x reaches that limit, whatever I have provided. So inside what it is doing, now I'll have something called a yield statement. Okay, so yield statement does what? It is just simply doing what that list iterator was doing, right? So you wrote print next of the list iterator and it was printing the next item. So now we have something called a yield statement. Let's see how this works. So if I write yield x squared, that is x into x, and let me have, you can have as many yield statements as you want inside a function. So let me have one more. So yield yield, why is the enter not working? Yeah. So let me print also the cube of this. Okay, x into x into x. And then I have to keep on incrementing x. So how long will I keep on incrementing? Until it reaches the limit. So the limit can be anything you want to set. If I set it 5, then it will calculate the square and the cube of every element from 1 to 5, right? For 0, it's always 0. So obviously x is starting with 0. So the first yield statements will give you 0 only. But after that, it will iterate from 0 to 1 to 2 to 3 till 4. And then as it reaches 5, the limit will expire. So how this, we can call this function. Now, if I in general call this, okay, if I didn't use the yield statement, what do you think will happen? If I did not use the yield statement, I just used just a normal print statement, print x star x and x cube. And then I call this square function with, let's say, limit as 5. Then what do you think will happen? Forget about the yield statement. Normally, what should happen? First iteration, what should it print? When x is 0, it should print 0, 0 for both square and cube, right? Next iteration, it will go, x is incremented to 1, so it will print 1, 1. Then 2 and 8, 4 and 8 for x value 2.
No,
9 and 27. 16,
Like this.
64.
Then it will stop.
Yes, ma'am.
Until which limit it will go, ma'am?
So whatever limit you specify. If I specify limit as 5, so x will go till 4. Right?
0 to
x, yes, 0 to 4. So if I did not use the yield statement, this is what will happen. But since I have used the yield statement, now how can I extract these values? Okay. So now outside of this function in the main program, let me have any variable a. Inside that, I'm calling this square function with some limit. Let's say the limit is 5. Okay. Now, previously what we were doing in that basket, that scenario, so we have to write print basket next. So it will print the next value in the list. But now we don't have a list or anything. We just have a function. We want to print the values that this function will generate. Now this function can generate two different values, the first yield statement and the second yield statement. So for this, now if you want to extract the values, you have to write print next of a, comma, next of a. So what will this print? Let's see. So it is printing 0, 0. What will happen if I just print 1 next of a here?
Ma'am,
So
A is not an iterator.
Sorry?
A is not an iterator, no?
No, this is a generator. Okay. So now we are not using the iterator function. We have just generated this using the yield statement. That now I don't need an iterator function. Rather, I can use this yield statements to get the values whenever I need. So if I just want to execute the first yield statement for the first iteration, okay. So inside a variable, I'm calling the squared function with limit 5. Now this function won't print anything until I call the print statement outside. Okay. Because of these yield statements. So when will this yield statements print? When I call the print outside in line 8. Here I wrote print next of a. So it will go to the first yield statement for x value 0. And if I write next of a, comma, again next of a. So now it will, this second next of a is for the second yield statement for the x value 0 only, for first iteration. So this is printing 0, 0. Now if I write one more line of this, next of a, again next of a. So what do you think this second line should print?
1, 1.
1, 1, man.
It is printing 1, 1. So like this, I can also take just one of this. Let's see if I remove this second next of a. What should this print?
4, 8.
Am I calling the second yield statement?
Only 4.
If I run this, it will print only 4. So for each of these yield statements, if you want to print it, you have to use this next function separately. Okay, one next function will just print one yield statement.
If you put the next line print statement at 11 line, you can put, then it will be no. Here only one next.
Okay.
You can copy and paste to the next line.
Yeah.
Only one next, not two. Okay.
See, every time I'm saying next, right, it will just print the next yield statement.
Okay.
So here also it will print 8. Now after this, if you print one more next of 8, now it will go to x value 3.
3.
So it will print 9 first.
Okay.
If you call it 2 times, then it will print 9 into again 3, so 27. 9 and 27 both.
Yes, ma'am.
So every next statement is for one yield. Okay. And
Yes.
every time 2 of the yields are completed printing, it will change the x value. And then again, you can call it as many times as you want until the limit is exhausted. So is this clear?
Ma'am,
Yeah.
can you hide this pop-up?
Can I have this? Sorry.
Can you hide this pop-up?
Okay.
Ma'am, what this iter function return?
No, there is no iter function here. This is a generator. Okay. So this
Previously,
yield
I
statement.
forgot to
Previously
ask.
we used this one is the iter function. So this is an iterator. Here basket became that list iterator object using which we can traverse the basket and using which we can traverse the fruits list and print the elements whenever we want. Now instead of having a definite iterator like this, a list iterator like this, now we have a generator. So a is this variable inside which we call the function. So this function will generate the values of x, like whatever values we want to print that we have inside the function. So we have x squared and x cubed. So these values will only be printed when you call the next function, that is next of a. Okay, so every time we call two
What
next
if
of
we
a,
want to print only fifth line? X
fifth
cube.
line, only this one. No, first you have to print the first line. So the yield statements will go in order.
Okay.
None of this is random. It is all just different ways of writing an iteration. Yeah.
So iterator is only for list and this yield is exclusively for everything.
Yeah, this can be for any function. Okay, this is not specific to lists. So this is better to use a generator since it's more in general. You can write this for any function. Just use the yield statements so that those values will be printed or yielded when you call the next function. Okay, so without your permission, this just calling square function will not print anything. Okay.
Scenario we can choose this thing.
Yeah, there can be different scenarios. So sometimes when you write code, so let's say you have any such function that just when you call a function, what does it do? It will execute whatever is in the function definition, right? And if there is a print statement, it will print it.
Yeah.
Okay. But in case of a generator, what happens is that you will call the function, but instead of print statement inside the function, they have yield statements. So these yield statements will only execute when you write this print statement outside of the function in the main program.
Okay.
So for every yield statement, you have to print one next of a. Now, once you call this next of a 2 times in this particular case, since there are only 2 yield statements in one loop iteration. So once you call those 2 next statements, so both of the yield statements are executed and then x's value will be incremented. Then when you call next of a again, it will be for the next value of x. So again, it will start from the first yield statement only. So it will go in order. Okay, you cannot skip one value. All right. Is the difference between iterator and generator clear? See, iterator, we particularly use that iterator function and we create a list iterator object. But here we don't do that. Here we have this yield statement. So you can generate it whenever you want. So these are called generators. Okay. Now these two implementations we might have in the upcoming weeks. In this week, only up to this you are required to know. Okay.
Ma'am, can you go to the iterator? So this iter returns an object, right?
This iter function basket equals to iter fruits. So this makes basket as an list iterator object for this list fruits.
So if we print iter of fruits, it will give object?
You cannot print iter of fruits. It's a function. Okay.
Yeah,
It
it's a function.
creates a list iterator object. That's the job of iter function.
Yeah, so it
you
will
can
give
print next of basket.
So it will give the address of it, no? Like
Give what?
Like it will give some address of the object, no?
You're saying if
If
I
you print
write this,
iter of fruits.
This. See, it is just saying that
Yeah,
it's a
it is
list
giving the
iterator object. Yeah. So whatever object it
so
is
if we
created, it is just giving the type of that object.
Yeah. So if we typecast it to list, will it give the list of fruits?
No, this is not a list, right? This is an object. Basket is not a
Yeah,
list.
this is
Basket
an
is just
object, but we can typecast it, no?
Like
we typecast zip, map.
Yeah, like zip.
That we can
So
do.
you're saying if I write it like this.
Yeah.
Okay. Let's see. So it will give the original fruits list. Like it will give the list for which basket is the iterator.
It will give you the exact list.
Yeah, it will give the list for which the list object we have created. Since already you have given the fruits as the parameter, so it will just give the original list. Okay. So a few more functions we have to discuss.
I think 3 more. Not that much.
Yeah, a few more are there, like lambda functions we have to discuss, and then there is that zip is there, filter, map, these things we have to discuss. First, let's start with this one.
Yeah, if I will not write next, then it will not work.
No, as long as you don't give the command for printing, it won't print anything. Okay. Both in case of iterator and generator.
But when you are printing next A, it is starting from 0, okay? And inside the first print statement, you again write the next A. So
yeah,
it could
the
be
first
0 1, na? Why Python is designing 0 0?
No, see, in this first print statement, when I write next of A, right? So first x's value is 0 currently. I haven't yielded any of the statements, so x starts from 0. For the first yield statement, I wrote this first next of A. Now for the next yield statement also, if I want to extract the value, I'll write one more next of A. But for both of these yield statements, x value remains 0 inside the function.
Oh, x value isn't changing.
No, x value will change after I have executed this yield statement. Then x is incremented by 1.
In the next print statement,
yeah. Next again, when you print next of A, so now x has become 1. So the yield statement will be 1 cross 1. And then again 1 cross 1 cross 1.
And after that,
x is changed to 2. Then it will print 2 cross 2, 2 cross 2 cross 2, like this.
4 8. Get it.
Okay, so let's quickly write a lambda function. So what is a lambda function? Why we need it? So lambda functions are basically anonymous functions. Okay, you don't have to assign it a name. So you can just use a lambda function. You can write the function definition in one line. So it's much easier to write than any general functions. So for example, let's say if I write a function like this, let's take some very easy function. So let's say def add x comma y. Okay, so it will just return your x plus y. Similarly, we can again write def sub. Yeah, sorry.
Can you zoom the?
Yeah. Sorry. Okay. So if I write def sub, then this will just return x minus y. Let's write a few more. So we can write def multiply x comma y as parameters. This will return x star y. And let's write one last. So def division.
Instead of writing x into y, we can write na return mul.
Yeah, that is also good. So x comma y, then you write return x y. Okay, so these are 4 different functions I've written. Now after this, in the main program, if I write print add 10 comma 20, then print sub 10 comma 20, for all of them I'm just writing one function calls multiply 10 comma 20 and print division 10 comma 20. So now if I run this, it is giving all the results, right? 10 plus 20, 10 minus 20, all of these. Okay, so instead of writing all these separate functions, if I want to write them using lambda functions, so what will be different? Okay. What I can do is, instead of just writing all these definitions here, so for add, okay, I'll just remove this function. So I'll take a variable called add. Okay, inside this I will write the definition of the lambda function. So you have to write lambda x comma y. Now you define what does x, like this lambda function takes x and y as argument or parameter, and what does it do with these two? Yes, sorry, are you asking something?
Oh no, I'm saying it returns x plus y.
Yes, so you have to define after the colon, you just define what it does with those. Okay, similarly for sub also we can write, so write sub equals to lambda. So this lambda functions don't require a name in the function definition. Okay, so you can just assign it to a variable. So x comma y, you can write x minus y. Similarly, so these are just becoming one line definitions. Now this might seem redundant since these functions that we just wrote are already almost one line functions only. Now for bigger functions, that's where lambda functions will make more sense. So instead of writing all of that code, you can just write it in one line. So I'll give you some examples using bigger problems. So x comma y, here we can define, it will just multiply these and then take this division lambda x comma y, it's supposed to divide x by y. Okay, so now when I call these, it is still returning the same value. Okay, so instead of writing proper function definitions, you can just write a function using lambda functions. Okay, and you can assign that to a variable. So now this function name will remain add only, since you assigned this lambda function to add variable, right? So when you want to call it, you have to call the add variable with this xy parameters that you have assigned to the lambda function. Okay, so if I write print type of add, so what is add? So type is function. So you can see that add is still a function. It's just the definition is a lambda function definition. Okay, so it's just a different way of writing a function. Lambda functions are easier to write. They're more straightforward. Now few more things are that we need to learn is, okay, let me save this file first. Now what we will see is something called just a second, something called enumerate. Okay, now why do we need that? See, if I have that previous, okay, let me take that fruits list. Yeah, this one. Okay, if I take this fruits list, now if I simply write okay, for fruit in fruits, print fruit. So this should print what? All of the list items, right? Oh, sorry, I didn't write fruit. Okay. Yeah, this should print all of the list items. Okay. Now, if I want to print the index, so if I want to print the index for each of the list items, how can I print the indices along with the items using a for loop? So I can just write for I in range length of fruits. Now inside this I can write a print statement, print I comma fruits I. So what should this print? What do you think?
It will print index with fruits name.
Index along with the items.
Yeah.
So it is something like this. Okay, this last 5 lines. So mango is the 0th index, apple is the first index. So like this we can print index. Now what is a better way of doing this? If I want this in the form of a list, that each of these index and item together, right, they should form a list. If I want to print it like that. So for that we have a function called enumerate. Okay, so instead of writing all of this, if I just write, okay, let me delete this. Here if I change for fruit in, so you can just put the enumerate function here, enumerate fruits, and then I do print fruit. See, if I run this,
Ma'am, spelling is wrong.
oh sorry, this, right? Yeah. See, now this is giving me, so each of the elements are a tuple, right? So a tuple contains the index as well as the element. So this is just a, you can say, a better way of indexing. So at index 0 I have what element present. So if you want to check that in case of any list and you want to check them in a more structured manner than we did with the for loop, this will print in each element in the form of a tuple. Okay, and tuple will contain 2 elements, index and the item itself. So here we don't have to use that extra I variable in my print statement, that I comma fruit I. Enumerate function will do just that for you. Okay, so this is enumerate. Now, yeah.
Will it work for sets and doubles also?
Let's take a set. So if I convert this into a set, okay, this is a set. So first you tell me, is this possible? So I can definitely traverse through elements, right, in a set. But what happens is that in a set there is no particular order. Okay, that's why this doesn't make much sense in case of a set. Whenever we transform, whenever we have elements in a set, right, they're not in any particular order. Like in list we have a particular order. So in set, when you call the elements, they might come in any order. So we know that in our list mango is the first element, so it should be in the 0th index. But here see pineapple is at the 0th index, because set doesn't conform to the indexing laws like that. It takes any element at any position. Okay, so it will take in random order. And definitely
I have
you
doubt
can,
here.
yeah.
Sorry for the interruption. Where in the statement where you're printing that for fruit in enumerate, how does it actually consider that the plural and singular? Because your fruits, I could understand it's a list, so it is fine. But how does it take for fruit as something which is an element inside the fruit?
Yes, just like you write for fruit in fruits. So fruits is what? A list only, right? And fruit is every element. Yeah.
Yeah, I'm actually trying to understand how does it really what do you call think that it's a singular, so fruit singular to plural thing, because here is a plural form fruit, so it's a set of elements is fruit. But when you say fruit, how does it actually, because we didn't define predefine anything.
It is just a iterator variable type. I can use I also.
Okay. Okay, fine.
Here if I use I, this is a set now, but it will still print the same thing.
Oh, yeah. Okay, fine. Okay, thank you. I thought it actually understands the.
No. You can use anything. No.
Thank you.
Okay. So enumerate just does this. It just takes this into a better structured indexing format. So let's keep it as a list only, since for set this won't make much sense to do all this. So next function that we have to write is a zip function. Okay, so what does a zip do? So let's take this same thing. Okay, this fruits list. Now let's have one more list where I have size. Okay. So this size is nothing. It's just a random list I'm taking and I'm assigning some random sizes. Let's write 5, 6, 9, 8, 7. So I want each of these sizes to be associated with each of the elements in the fruits list. Like 5 should be associated with mango, 6 should be associated with apple, 9 with banana. So like this it should go. The first element in size should be associated with first element in fruits. Second element in size should be associated with second element in fruits. Like this if I want to go. If I want to print the size and the fruit together. Okay. So for this we can use something called a zip. Okay, a zip function. So how we can do is, we don't need a loop for this. So we simply can write print. So if I want it in the form of a list, I will write list of zip of. Now you have to give the arguments. Okay, what lists you want. So I have fruits and I have size. Okay, so if I run this, it will give me each element with its corresponding size as a tuple as an element inside a list. Now instead of this list, okay, if I write this same print statement, but I remove list and in this place I put a dictionary, then it will print it as a dictionary as well. The first it is printing as a list, where inside the list each of the pairs are a tuple, and when I print it as a dictionary, then the first list that you pass as an argument becomes the key list, and the second list that you pass as an argument becomes a value list. So if I just let's say if I just change the order, so I write size comma fruits, then what should happen? So the first element, the first list that we pass, that becomes the list of keys. The second list that I pass becomes the list of values. So you can get the result in any form you want, list, dictionary, whatever you like. Okay. So this is good if you want to, yeah.
Could you please explain the final thing where the swapping is happening?
Where the swapping?
Yeah, you mentioned that.
Yeah. See.
First line.
What I did is, so I want to associate the first element of size with the first element of fruit, second element of size with second element of fruit. Like this, I want to associate every element with its corresponding element in the other list. Okay. So for that, I can use this zip function. So the zip function will take these two containers or lists as its arguments. Okay. Now, depending on what order you are putting the arguments in. So since I put fruits first and then size. Okay, so it will first take the element from fruits and then take the corresponding element from size, put them in a tuple, and that tuple will be the element of a list, since I'm printing the whole thing as a list in this third line. Okay, here if I swap size comma fruits, then it will just inside the tuple. Here we have mango comma 5, it will just be 5 comma mango.
True.
Okay,
yeah.
So it will work according to the order in which you have provided the arguments. Now I can also print this in the form of a dictionary. There the argument order will matter how. So if I put zip size comma fruits, then size becomes the list of keys of the dictionary and fruits will be the corresponding values. But if I write dict of zip of fruits comma size, then fruits will become the keys and the corresponding size values will become the values of the dictionary. So order of argument is important here. Okay. So that is your zip function. Now one more.
So the line number 4 is the line number 4 is the right form, or here is not the
anything you want. Okay, so if I, since here I want fruits and corresponding size of fruit, so it makes more sense to have fruits as the first argument, so that fruits are the values. Okay, because two fruits can have the same size. Here I can write 5.
Size, yeah.
So that won't make a good key, right? So keys have to be unique. So this is good. Okay. Now, one more next function that we'll deal with is called something called map function. Okay. So,
Ma'am,
yeah.
before you go for a map, I have a doubt about zip. Supposing if these iterables are of different length, will give an error.
If the iterables are different length, right? So if I remove one from size, then what will happen? See, so it will not take the last element from the first list. Whatever is the smaller list, only that many elements will be returned. So for pineapple here, we won't have a corresponding size, so there will be no entry. So it will take the smaller list. Okay, that will be the size of the list that it's returned. All right. Okay. See, now one, yeah.
And ma'am, can those iterables be of different data types? Can the size be a set?
If the size is a set, this I haven't tried. This I also don't know if it can be. I don't think so. Let's see. Could be. Yeah, it will work. So here it is returning. But in case of set, what happens is that it won't take any duplicates, right? So it will take 3 elements now because 2 of the sizes are same and set doesn't allow duplicates. So it will just take 8, 9 size. So they can be of any type, list, set, whatever you want.
But they were stored inside like in a tuple.
You will decide that if you want to print it like a list in the form of a list. So the first statement here I'm printing in the form of a list. So inside this, every element will be a tuple. But if I print in the form of a dictionary, then every element will be a key value pair. Okay,
inside
just like
list
here.
all of inside
Yeah,
the
inside list
all of
all
them
are
tuples.
tuples. Yes, all are
Okay.
tuples. So these are all immutable. But inside dictionary, they're just key value pairs.
Okay, ma'am.
So if you convert it to tuple, then it will give a tuple of tuples, right?
Yeah. Let's write one for that too. So
Ma'am, in fourth line, if we print size and fruits, then dictionary can't contain two similar keys.
Yeah,
So,
exactly. So it won't happen if you put size as the key.
Okay.
That's what I said, that's why the order matters. So it won't take duplicates, right? So in that case, what will happen if I put size as the key, then it will just take the 5 once. Okay, it won't take the duplicate. So one entry will be less then. So if I put it as a tuple, let's see. So it will just be a tuple of tuples. Okay, so you can print it as any data container as you want.
And is there any limit for the number of arguments in zip?
It will be 2 arguments only, no? Because
No, it will work for 3 also.
No. In this case, I'm saying because we have only 2 arguments here. Okay, you're saying in general.
Yeah, in
Here we
general.
have only fruits and size. Okay, let's take one more. Let me take some x. Okay, let it be one more list. If I put some elements here, let's say 11, 12, 13, 14. 4 elements I took. Now here if I write fruits comma size comma x, and let's remove these 2 statements, what will it print? So it will just take 3 values in one tuple. So any number of lists or sets you can take, it will just take the first element from every one of them, form a tuple, second element from every one of them, form one other tuple, like this. But
So,
in case
ma'am,
of set, what happens, that order will not be maintained. Okay, so we don't know what is the first element, what is the second element. Set takes in random order. That's why the size is not being 5, 9, 8. See, it is starting with 8, then 9, then 5. Okay.
Ma'am, so here exactly Jeep is what? Jeep's exact work is what we can.
If you want to let's say form a dictionary from 2 lists, one of the list is the list of keys, one of the list is the list of values. So instead of writing that entire dictionary or going through both the lists and creating key value pairs, you can just use the zip function to print the dictionary.
Okay.
These are just one line ways to do it from actual data.
But if I'm not actually using neither list or tuple or something, just print zip, what will be the string output?
See, if I just write zip,
It will give an object.
it will just tell you that it's an object. So this is just printing what is zip. So it is a zip object. Okay, so you have to, if you want to print the elements, you have to print it in some data container, right? Either it has to be a list or dictionary or whatever, tuple. Just like there when we printed basket. So what is basket? It's a list iterator object. So it just gives the type. Okay. Now let's do this. So now let's say I have a list.
Sorry to interrupt. All these things, whether in terms of zip, whether in terms of enumerate or iteration, do they have any kind of what do you call the pros and cons of it? Do they have any limitations there?
See, these are just functions, okay? So they perform a particular set of tasks, like any function.
Okay.
So these are like these functions. They are sort of built in, right? So we are not writing the definition from them. It already knows what it does.
Okay. It's a system coding.
Yeah, just like a print statement.
Okay.
Ma'am, hello.
Yeah.
Ma'am, define key. What's mean? Key
Which key?
In dictionary, you mention key.
Yeah.
Then I'm not able to understand the key in dictionary.
I'm not getting your question.
When you zip with dictionary, then it output dictionary and
see if
key.
I put these two lists, okay, forget about size. If I put fruits and this X list, okay, so I want to print this in the form of a dictionary.
G.
So here
Yes.
I will just write dictionary of zip of, since I don't have size, let's remove it. So what this will print is, one more bracket here. So what this will print is, it will print a dictionary. The keys of the dictionary will be the first list that I have passed as argument. So the list of fruits, that is the keys of this dictionary. Okay, and each of these keys have a corresponding value. That value X, that value is coming from the list X, which is passed as the second argument. So this will depend. If you put X first, then X will become the keys and fruits will become the values. So whichever order you take first, the first argument will be the key and the second argument will be the value.
Okay, ma'am.
Okay. So if I print this, see, mango is to 11, apple is to 12, like this. Okay, now let's create two different lists. So this is the first list, let's say 10, 20, 30, 40, 50, 60. Let's take these elements. Then let's say we have one more list B. So this has elements 5, 10, 15, 20, 25, 30. Okay. Now is it possible to, if I just write A minus B, will it subtract two lists? Is it possible? Can we do this type of operation on lists?
No, ma'am.
This type of operation is directly not possible on list, right? You cannot subtract two lists. I can concatenate them. I can just write a plus sign and concatenate two lists. But subtraction is not possible like this. So if I want to subtract every element of B from every element of A, corresponding elements, then I would have to iterate through each of the elements in A and B and then write a code to subtract them, right?
Or we can use map function.
Yes, so here is where we use map function. So how I can do this subtraction, that is I want to subtract this first element of B from first element of A, second element of B from second element of A. Yeah.
We can do set of A minus set of B.
Set of A minus set of B. Yeah, if you change the type. No, I'm talking about lists. In list, is it possible? I'm not changing the type.
No.
List doesn't allow subtraction operation, right? Or that type of arithmetic operations. It allows concatenation. So here I can define a function. Let's call it sub. Inside that I'll have two arguments, x comma y. Okay. So this function is supposed to return x minus y. Now how can I use this to subtract each element of B from corresponding element of A? So I have defined the function. Next I can write C, just any random variable. Inside this I will assign the map function. So map, now inside map function, first you have to write the first argument that this map function will take is what is the function that you want to execute. So I want to execute the subtraction function, right? So I will write sub. Now based on what will this operate on the two lists that I have, so A and B. So I have to pass them as argument as well. So C is taking the subtraction function as an argument and the two lists on which I want to perform this subtraction. Okay. After this, if I write print list of C. So whatever is the result, I want to print that in the form of a list. Now if you run this, see it is giving this list, which is subtraction of every element of B from every corresponding element of A. Okay, so what will happen if I change the order? If I write B comma A, then run it. So it is giving some negative values because obviously A has bigger values than B. So now it is subtracting values of A from values of B. So that depends on your argument. But the first argument should be the function that you want to execute on these lists. Okay, so this is one way of performing list subtraction. This is an easy way.
Ma'am, instead of this, we can use map, list map, and the lambda function, so that
Yeah,
we
lambda
can,
function also you can use. Yes.
So this function line 4 is replaced by that.
Yeah.
We don't
Then you
need to-
define the lambda function.
Yes, ma'am.
So sub equals to, you take the lambda x comma y, x minus y, and then in map you call that function.
Yes.
Okay. It's the same thing. So lambda functions are just one line definition of a particular function, nothing different. The order is important here inside a map function is because the first argument should always be the operation that you want to perform. And the next arguments can be your actual data on which you want to perform the operation. Okay. So I can put this in the form of a list. So this is your map function. Now, if I write one more function, let's say here, if I write some function that increments the value. So let's write function def increment. So
sorry, could you increase the font, please?
Yes. Okay. So def increment. So this function does nothing but just increment the value by 1. So x plus 1 it will return. Okay. So I can create, let's say, the map. If I write incr comma a and then print list of C. So okay, wait, incr ement. So this is just incrementing. So it printed whatever is mapped to C in the last line, right? It is not taking this line 11 into account now. Okay. So it is just taking this second line, that is whatever is mapped to E finally. So last mapping is this increment function. So it is just taking that. Okay. So if I just name them differently, if I write D map increment A and then I print list of C and here I print list of D. So it will give me both. Okay, the subtraction as well as the increment function. So you can write as many functions as you want and you can map them to whatever data you desire. So just one more thing is left, which is called filtering. Okay. So why we need that, first of all? Okay, this is clear for everyone? Map?
Yes, ma'am.
Yes, ma'am.
Okay, so the last topic is filter. Okay, so let's say I have okay, let me take the math library. So I'll write import math. Then let me have some list A which contains square root elements. Okay, so 50 and 25. Let me take minus 16. So the 16 is a square, right? Next I can have 9, just some elements I have in this list. 81 I can have, and let's say I have minus 100. Now if I define a function called def square root of n, I'll take any number n and I'll get the square root of that. So I can just use the math.sqrt function from this math library. So I'll write return math.sqrt and I'll give n as argument. So what is this going to return? The square root of the number n, right? So here if outside, if in C, okay, I map. So what is my function name? That should come first. That is what is the operation I want to perform. I want to do a square root. So I will write square root first. And on what do I want to perform the square root? The elements of this list A. So I put A. Okay. Now after this, if I write print list of C. So there is an error, math domain error. So why is this math domain error arising? Anyone? Why do I have this error?
Negative values.
Right. So if I have negative values, square root of negative values is imaginary number, right? Root over minus I. I cannot take that. Negative values I cannot take for square root. So how can I filter out these values and still get the square root of the other values which are valid? One thing is to the naive approach is that you go through every element and then discard those elements which are negative and find the square root for other elements. So how can I write this code in a more efficient way? Okay. So here is where we will use something called a filter function. But for that, I would need to write something. First of all, how do I identify which value is positive, which value is negative? Right. So for that, I will write some function. Let's call it is positive. So def is positive. It will take some number n and will check whether this number is positive or not. So if n greater than 0, then return n. Otherwise, don't return n. Yeah. Okay. So is positive can check that whether a number is positive or negative. It will only return the positive numbers which are greater than 0. Okay. Now if I again call this map function. Okay. So inside of map, I put square root. But after that, I won't put A. What will I put? I'll put filter is positive. Inside of filter, I put the argument says is positive, comma A. So what is this doing? This filter function will filter out all the values which are not positive from this A list, right? So it will take every element from A list, pass it through this is positive function, and this is positive function is going to return only those elements which are positive. So filter function is going to filter out all the negative elements and we'll be left with just the positive ones. Okay. And then that will be passed through this outer map function. So on this positive element list only, now the square root operation will execute. So see, this gives me all the correct values. So 5.0, 3.0, 9.0. That is for 25, 9 and 81. Minus 16 and minus 100 are filtered out. Okay. So you can write any such filter function, like here I wrote is positive. You can write any such function to filter out certain values from a list.
Ma'am, one question here. Without filter, we can here simply pass in the map function, we pass is positive function with argument A. It will also give the same result.
Just after map, if you write is positive comma a.
Yes, like square root comma is positive in bracket a.
No, two of these you cannot pass, right? See what will be the problem. I'll just comment this out.
Okay.
So if I write c equals to map,
Yeah.
inside this I write is square root. Then you are saying is positive.
Is positive.
Comma a.
Comma a. Yes, ma'am. No. In parenthesis. In parenthesis. Is positive.
Okay,
Because
is
positive
positive
function.
parenthesis a. Okay.
Yeah.
So a as an argument of is positive.
Yes, ma'am.
But can is positive take a list as an argument? Is positive takes only an item, right? Only an element. A is a list.
Yes.
So that's the problem. Okay, if I run this, it cannot take that. It is difference between list and int. So is positive can only take an integer as an argument.
Yes, ma'am.
So the filter function first has to filter out the correct elements that we need, and then you can put the square root function.
Yes, got it. Thank you, ma'am.
Yeah. So these are all the different functions that we have in week 5. Okay, every single topic I've discussed that is present. If you go through the lectures, you'll find everything we have discussed. Okay, nothing is left. So next class we'll just practice. Now one problem I have. Yeah.
Now, what is the difference between reduce and filter?
What is the difference between?
Reduce and filter.
I can't hear you. What filter?
Reduce and filter. Reduce. REDUCE.
Hello.
Ma'am, reduce and filter.
All your voices are breaking up. Can you hear me? Am I audible?
Yes, you are audible.
He's asking a difference between reduce and
Filter.
Filter.
Oh, you are asking about difference between?
Okay, difference between reduce and filter. Okay, right. So reduce is what? Reduce is a function that we apply. Okay, reduce function is used to apply a particular function that is passed in its argument to all of the list elements mentioned in the sequence. Okay. So this function is in a particular module, right? This reduce function is, I think, in the func tools module or something.
No, ma'am, I think that is also built in.
Dot reduce, reduce is from func.
Not dot reduce.
Yeah, but from you mean in reduce function we pass some function, like some lambda function we can also pass, right? And then some list.
Yeah.
So okay, let me write something. So if I write, okay, first I think I have to import that library, otherwise how can I use that function? There is some library like this. Let's say I have a list of numbers n. Okay, let's say 1 comma 2 comma 3 comma 4 it has, and then let me have a variable called product. Okay, so inside product, now if I want to use the reduce function, okay, so what will it do? So if I write func tools, this is the reduce function I have used. So reduce, then inside this I can have some lambda function. Let's say I'm finding product, right? So I can write lambda x comma y, which should generate x star y based on this list of numbers then. Okay, so now if I print, so what will this do? What do you think will this do? What should this perform, this line 4?
Lambda will perform the multiplication. After that,
yes.
Reduce, what will do?
So what it does is reduce will do this multiplication for every element in n. Okay. So it will reduce function, what it does is it computes the product or whatever function you define as lambda for every element in a given list. So it will continuously apply this lambda function for every 2 numbers together. Okay, so it will result in some final product. So if I use this function, that is this multiplication lambda function, for every two elements, so how should it look like? 1 cross 2, 2 cross 3, 3 cross 4, like this, right? So what should it give in return? It should print the product of all the elements together. So if I write print product,
You have 24.
it should give 24. Yeah. Okay, so this is reduce function. And filter does what? Filter will filter out the given sequence or whatever list I'm passing through it with the help of a function that will test it for something, like I tested whether it's positive or not. So filter is simply to filter out elements, okay, based on some condition that you define. And reduce will do what? Reduce will go through every element in a particular list that you are passing and then give or perform this lambda function or whatever function you have defined on every element of that list. Okay, these are two different methods. They don't have much to do with each other.
Is it similar to the map?
This reduce function?
Yes, ma'am.
Yeah, it is kind of similar actually. See, in map also we first pass an argument. The first argument is the like that increment one, right? So I want to increment something, and then based on the list of elements on which I want to increment is the second argument. Here also I want to perform product. What product do I want? Product of all elements in a particular list.
Okay.
But ma'am, the map returns an iterable object, ma'am. But reduce is giving some number.
Reduce will give the like ultimate result after doing all the operations together. Okay, so this will take every two elements in the list and find their product. But map, like here when we did map function, yeah. So map will find the square root for every particular element and then return that square root, right? But in case of reduce, it is finding the product of all of them together and returning just that value. So that totally depends on what is the function that you want to execute. Like there, the lambda function wanted to find the product. Here we have a square root function. The square root, how can I do square root of all the elements together, right? That has to be separate. For every element, the square root is different. But product I can find for every element together, all the elements multiplied together. So they are kind of similar, yes. But if you want to find like for all elements at the same time, then we use that reduce function.
Okay.
Okay, I have one problem that someone gave me, that how to find all possible permutations of a given word. Okay, a string. So is that person in the meeting?
Yeah. I'm waiting for the reply.
Ma'am, you provided us your email ID.
Yeah.
Is manidipa@study.itm.ac.in, na?
Yes, correct.
Okay. I am sending you the one thing in mail.
Okay, yeah, you can all just send me whatever code you want. Okay, like this person sent me this problem, so I did the
I have
code.
sent you question.
Oh, you sent that question that last day we did, that max frequency.
No, I just did the first one. That yeah, max frequency. Yes, I'm the one.
Yeah, I saw that question. I did not find an error. It is correct code only.
But
It should
I'm
give the right
getting
value.
one in structure.
Sorry.
I'm getting an answer as 1, maximum as 1, and the word as structure.
I am using that exact same code, but I am getting the maximum frequency as 2. Okay, and R is coming for me. Just can you do one more thing? Just take any random paragraph and check it if it's giving the correct. Just remove that, discard that paragraph. You take any random paragraph, okay, and use that same code. See, first you manually calculate what is the maximum frequency and then check if that function is giving the correct answer or not. Because it is working for me. I didn't understand why it's not working. Okay. Yeah, what was that thing? Yeah, word permutation, right? This one. Is it visible? Should I increase it further? This is okay?
Yes, ma'am, you already solved.
Yeah, but I didn't mail it to you because I just did this today only. I didn't get time before that. So I'll just explain the steps once, okay? If you don't understand something, you can let me know. So this has to be done using recursive calls. Okay. So we have done recursive calls before, right? You know what is recursion. When we call a function inside a function. Correct. So what is the main thing about a recursion? What is the one thing without which we cannot perform a recursive call? Base condition. What does a base condition do? Anyone?
It terminates.
It terminates the recursive call. Like in the factorial program we saw, that we were recursively calling the factorial function, it will stop when the factorial becomes 0 because 0 factorial is 1. Correct.
Ma'am, so class is over. Now we are taking extra doubts.
Yeah, this is just a program someone sent me. I'm just explaining it to him. Rest of you can leave. It is over. Yeah.
Thank you so much.
Yeah, thank you. Okay. So here what is happening is get permutations is the function that I wrote. Okay. So what I will do, see here, this is the example, this is the test case sort of. So here you can enter any word and then I'll print all the possible shuffle words or all possible combinations. So I have to call this get permutation function and take that word that you passed as a list. Okay. So I'll take the word as a list. So I have converted it to a list type. So the control will shift to def get permutations. So in get permutations, the word is the list of words that I have list of letters that I have provided. Okay, and then I have one more variable called step, which is assigned to 0. Okay, now I have to generate all possible permutations. So first, this is my base condition. Okay, I'll write the base condition first. If step becomes the length of the word, that is as many letters that are present in the word, then I will show the current permutation that I have computed. Okay, so as soon as step becomes number of letters of word, that is I have iterated through every letter of that word, I will print the current permutation. Now step starts from 0, right? So if my word is, let's say ABC is the word I passed. Okay, so first it will check step is 0. What is length of ABC?
3, ma'am.
3 is the length of ABC.
Yeah.
So 0 is not equal to 3, so it won't print anything. Base condition not satisfied. So you come to the for loop. So for I in range, step till length of word, that is length of word minus 1. So step starts from 0, length is 3, so it will go for 0, 1 and 2. Now for first iteration, I will make a copy of that word. Okay. So I got this word in the form of a list. I will make a copy of that list just so that the original list is not damaged in any way. Okay, so when I swap, permutation means what? I have to swap the letters of the word in every possible combination, so that this swapping doesn't damage the original word list. So I will just create a copy. So I'll call that word copy, and this just has the exact same elements as the word list. Okay, now second line in the for loop, I am just swapping the elements. So word copy step. So for first iteration, step is 0, I is also 0. So that means both are pointing to the first letter. That means nothing will be basically swapped here, right? Next line, get permutations, you call this recursive function now. This is a recursive call. In the recursive call, what is the argument? Word copy, that is the copy of the word that we just made, that list, and step is incremented by 1. Okay. So you again come to this function only. Now step is 1. So step is 1, length of word is still 3. So 1 not equal to 3, so come to the for loop. Now I will start from what? 0 or 1? In this inner iteration, I will start from 1 because step is now 1. Range is from step to length. So 2 iterations should be there. 1 and 2. I should have values 1 and 2. So again, you create a copy of the word. Okay. Then for every iteration, you'll create a separate copy. Okay. Because we are maintaining this copy. Why? So that we have the permutations in different lists. Now, word copy step. Okay. Word copy step. What is step? Step is 1. What is I? I is also starting from 1. Again for 1, 1, this is pointing to the same letter, so no swapping. So you call the recursive call again. Get permutations, word copy, that same list of letters, and step is now incremented to 2. So again here if you check base condition, 2 is equal to length of word 3? No. So again come here. So I is now going from 2 to 2 only, right? So what will happen? Here I is also 2, step is also 2, right? So again, no swap. So you just go to the backtrack to the last function call. So where I was 1, right? So I was 1 in the last function call. It started from a step which was also 1. But now the next iteration I will become 2. So it will be word copy 1, comma word copy 2. And they will be swapped. So in place of the second element, the first element will come, and in place of the first element, the second element will come. So like this, after every backtracking, one swapping will happen. Okay. And once you have reached the length of the word, that is once I again call this get permutations word copy step plus 1, step becomes 3. Then this base condition will be satisfied, and whatever is present in your word list, right, you are just going to join that into a string. Let me give you one example. Just a second. I'll share that. This is a little difficult to understand also without proper example. Right. Let me paste this in a doc, then I can show you. Otherwise, I have to write the whole thing.
Ma'am, I will guide you in Colab. I will send you a video link of IIT Madras.
Yeah, that will be good. Okay, just send me that. I'll check it out. I'll add the note.
I have a 15-20 minute video. If you watch thoroughly, then it is not that much rocket science.
Okay. Yeah, just send it to me. I don't have any access to these things, so I don't know.
Colab access, actually you have to
I have to create, right, one file.
One file, you can create multiple files. There is no restriction like Replit, that thing.
Okay. No, I haven't worked on Colab much, so I don't know. You just send me the video, I'll check it out and I'll do accordingly. Okay. Is this visible, this doc file? Can you see?
Yes, ma'am.
Okay, so this is a step-by-step explanation for that. Okay. So let's say I take ABC. Now I want every possible combination of ABC. Okay. So first function call, I write get permutations of list ABC. So the list elements are A, B, C, like this. The initial call, what will happen? Get permutations A, B, C, step is 0. So step 0, so I will loop over 0, 1 and 2. And it swapped the characters at step and I. So we saw that word step, word I is equal to word I, word step. So that is just basic swapping. Right. So first level of recursion when I is 0. So no swap will happen because both step and I are 0. So if both are pointing to same letter, that means no swapping. Right. So next recursive call is for step equals to 1 because step is being incremented now. We are passing that same word copy. So this is a copy list that we made, right? Okay. So now the function is called with step 1. So I will loop how many times? 1 and 2. So for loop iteration where I is 1, again no swap because both step and I are 1. Okay. So I move forward to next iteration where step is 2. Again I and step are both 2. So no swap. So now since after this next iteration when I again recursively call this same function, step becomes 3 at this increment. So this 3 is nothing but the length of the word. So base condition is met. At that point, what is present in my list? A, B, C. So I'll just join them with that string join operation, right? So at that point, ABC is printed. This is the first permutation of the word. Now I'll backtrack. So if I go back to where step was equal to 2, that recursive call, I haven't yet finished all the iterations there, right? I just did with I equals to 2. So now I will again go back, okay, and I will return to step equals to 1. Now step is 1, but iteration for I is 2. So which two elements will I swap? What is the first element? That is not the 0th element. The first element in my list is what? B. A comma B comma C is my word copy list. So the number 1 index is what? B. Number 2 index is C. So I will swap these two indices. So it will become ACB. Okay. And it will proceed like that. So basically this is why this is difficult to understand is if you don't write the dry run yourself, you won't get it. Okay. So for any random, like just take a small example like this, ABC. How many possible combinations can you get? So you handwrite the recursive calls yourself and see that once you go to a recursive call, then it's calling one more recursive function till the base condition is met. Once base condition is met, you again come backtrack and finish the loop iterations. Okay. Just a second. Okay. So do you want me to share this doc with you? So you can match the recursive calls?
Yes,
ma'am. Why not? It will helpful.
Okay, I'll share it then. Where can I share this? Are you on Discourse?
Yes, I am on Discord. We just copy doc link on paste it in the chat.
Yeah, I can just paste this here, right? But it is not a link.
I think in chat you can drop.
Yeah, I'll generate one link.
Oh, it's a Microsoft Word document.
Yeah.
Oh,
But
then
I can generate a link for it. Wait.
then you
I can
can.
just create a Google Doc and paste this same thing there. Because this type of problems are very difficult to understand if you don't write the dry runs yourself. Recursive calls, right?
Yes, ma'am.
Okay, let's put this here. I'll write word permutation document. Dry run. So I'll just give you viewer access, okay?
Yes, ma'am.
Okay. Please check if you can open the link I've pasted in the chat box.
Ma'am, it is not accessible. Request access.
What is it saying?
Request access.
Access denied.
Access denied. Just.
It is opening, ma'am. I can open it.
Yeah, I can see someone is opening it. Okay, wait. I think it's just shared with one person. Okay, I'll share with all of you. Wait.
I think
Wait,
there is a file permission. You need to change the file permission with
in
the.
share it will be present. Yeah,
Yeah.
got it. Okay. So I'll just make this anyone with the link.
Yes.
Okay, now you check.
Yes.
Accessible.
Accessible.
Okay, so just do your dry run and match with this document. Okay, if you get the correct combinations, it will match. All right. So okay, let's wrap up then. Next,
Ma'am, have
yeah.
you more that like document for
No, I just created this one for because he asked this. He sent me this problem over mail. So if you have any more problems like this that you want the code for, so I'll give you the detailed explanation and the code.
Okay.
Okay.
Ma'am?
Yeah.
Can you please explain the local variable and global variable once again?
Oh, right here.
Ma'am, have you received any mail on your official mail ID?
Yes, I got a lot of mails. I shared it with the team. Regarding that GRPA submission, I think a lot of mails were
No,
there.
not GRPA. I have sent you now a link, a video. Have you received?
Oh, okay. Let me check. 1 second, huh? Yes, I got it.
Yes. Dibba Majumdar.
Yeah, thanks a lot. Okay, I'll check this out. Okay, is my document, this spider is visible? Okay, can you see the
Yes.
variable scope file?
Yes.
Okay. So local and global variable, what is the difference? Global variable scope is throughout the program. Local variable scope is just inside the function. Okay. So in line 9, I have taken this variable x and assigned it the value 5. So this is a global assignment. Okay, this is not inside any function, right?
Okay.
So this is a global variable. Now, after this, if I write, okay, let me keep it this way only. If I write my function 1x, so I am calling my function 1 with the value of this variable x, right? This is called by value. So when you go to my function 1, then x will be updated to what? X into 2, that is 10. Right?
Yes.
Inside this, when I print value of x in function 1, so it will show x as 10. But this change that occurred, this change is only valid inside function 1. Globally, the variable x is still storing 5. So local variables are sort of like just a copy. Okay. And they are valid only till that function. Once the function closes, those values are not valid. If I change x's value globally, like I did in line 15, then x will reflect 10. Okay. Global means in the main program, not inside any function. So if I print this, see, first value of x in function 1 is 10 because what is my first print statement? In the main function, I first assigned 5 to x, then my function 1x I called. So control will shift to my function 1. Inside this, locally x is updated to 10. So here I am printing value of x as 10. So first line of print is 10.
Okay.
Next in line 11, print the value of x before function call I have written. This is basically a print statement in the main program. So whatever x value this print statement prints is the actual global variable x, whose value has not changed. It is 5 only. So this line is printing 5. Next I called function 2 with again parameter x. So this x value, this parameter x is what? 5 only because this is coming from the global variable.
Okay.
So once I enter function 2, I update x. So now x becomes 15, but this is just a local copy and it's valid only inside my function 2. So it will print 15. See, value of x in function 2 is 15. After that in line 14, I'm again printing value of x after function call. So did it change the global variable? No. So this is still 5. This line.
Okay.
Then I changed x globally. So I reassigned x to 10. This changes global. Now if I call my function 1x, this parameter will be now 10, not 5 anymore. Okay. So I will do 10 into 2, 20. So it will print the value of x in function 1 is 20. After that, if I print what is the current value of x in the main function, in the main program, it is still 10.
Okay.
So everything in the
so
main program is based on global variable. Okay. And whenever locally we take a parameter, it is just
It's
a
in
copy of
the
the global variable, and its scope is limited to that function only.
Okay, so whichever is inside the function, it's a local variable, and whichever is outside the function, it's a global.
Correct. So there is much more things present in scope of a variable, but in our syllabus in week 5 we only have this much. Okay.
Okay. Thank you.
Yeah. All right. Yeah. Thanks everyone. Thanks. I'll close the class then. Thank you.
Okay. Thank you, ma'am. See you soon.
Thank you,
Thank you, ma'am.
Thank you.